In this video, we will cover the use of the Global Lung Function Initiative (GLI) reference values for spirometry testing, focusing on the GLI race-neutral or global values. In 2012, the ERS Task Force released a document that contained multi-ethnic reference equations for spirometry for subjects between 3 to 95 years old. These reference equations were the result of collecting data on over 74,000 subjects in 33 countries. Subsequently, the 2012 GLI reference equations were endorsed by the ERS, ATS, the Australian and New Zealand Society of Respiratory Science, Asian Pacific Society for Respirology, the Thoracic Society of Australia and New Zealand, and the American College of Chest Physicians. From the results of the subjects tested, data was not available from all regions of the world. Some regions were excluded due to conflicting results. From this data, GLI was able to pull together all of the data and create 4 main ethnic groups: Caucasian, Black, Southeast Asian, and Northeast Asian. These groups combined subgroups from different regions of the world. GLI also created a 5th group called Other, which corresponds to groups outside the 4 main groups. Other takes the average of the 4 main ethnic groups and was to be used until a more appropriate solution was developed. While the 2012 GLI equations did not include all of the forced vital capacity variables, they included FVC, FEV1, FEV1 over FVC, FEV 0.75, FEV 0.75 over FVC, FEF 25 to 75, and FEF 75. One notable variable that is missing from this reference set is the peak flow variable. Unlike most other reference equations that use simple calculations to obtain their values, the GLI equations use lookup tables from which data points are used, depending on the subject's height, age, and ethnicity. Because of these lookup tables, if the subject's age is outside of the 3 to 95-year-old range, no predicted values can be calculated. However, in ASCENT 2.3 or higher, there is a method to override the age limitations. Using the main menu, click on Admin, then the Organization tab, then select Sites from the drop-down list. Here you can select the option to override the GLI maximum age range. This means that if you have a patient older than 95, predicted values will still be calculated. As an example, if the patient is 96, the software will calculate the GLI spirometry values based on the maximum age of 95. This override function operates the same for GLI DLCO and lung volume predicteds. It should be noted that the maximum age ranges for DLCO and lung volumes are different from spirometry. For DLCO, the maximum age is 90, while the maximum age for lung volumes is 80. In 2022, GLI released another document in which they reanalyzed the original GLI 2012 data to create race-neutral equations. These are also sometimes called global equations. This means that regardless of race or ethnicity, the same predicted equation will be used for all subjects. Very similar to the other category from the 2012 study, the race-neutral equations create an average from the 4 main groups. However, this average differs greatly in the fact that the 2012 other equations were heavily influenced by data collected on white Europeans, which composed more than 75% of the collected data. The 2022 GLI study tried to remove this bias, using a weighted approach to derive race-neutral equations and a lookup table, similar to the 2012 equations. However, the 2022 GLI race-neutral equations were limited to only a few spirometry variables. These variables are FVC, FEV1, and FEV1 over FVC. The predicted values for the 2022 race-neutral equations were less than 1% different from the values obtained using other in the 2012 equations. However, the limits of normal were up to 9% wider for FVC and FEV1. Since the FEV1 and FVC were proportionally different between groups, the ratio of FEV1 to FVC was not affected. Now that we have reviewed both the 2012 and 2022 GLI documents, let's look at the implications of using these predicted equations. In this first slide, we have the predicted values for a male at various ages, using a height of 70 inches. The predicted values for Caucasian and Black significantly vary from each other at all ages. The 2012 other predicted values are roughly the average of Caucasian and Black. However, the 2012 other predicted values are fairly close to the 2022 global predicted values, which would be expected. Looking at the predicted values for a female, we see basically the same similarities as we saw with the male subject. The Caucasian and Black predicted values varied significantly from each other, while the 2012 other and 2022 global predicted values were fairly close. The implications of using a race-based predicted value compared to the 2022 race-neutral predicted value can have significant impact on the interpretation of the results. For example, the FVC of a 40-year-old Caucasian subject using the Caucasian 2012 predicted equation would be 5.25 liters. On this same subject using the 2022 race-neutral equation, the predicted FVC would be 4.91 liters. Since the predicted value would be lower using the 2022 equation, this would make the Caucasian subject appear better when comparing a given actual value to the predicted value. Looking at the lower limit of normal on this subject, we see that the LLN goes from 4.18 liters using the 2012 predicted equation for a Caucasian to 3.78 liters using the 2022 race-neutral equations. Again, basing the interpretation on the 2022 LLN, this subject may appear to be more normal. Inversely, the predicted value for a black subject using the 2012 predicted equation would be 4.43 liters, while the 2022 race-neutral equation has a predicted value of 4.91 liters. Since the predicted value would be higher using the 2022 race-neutral equation, this could make the black subject appear to potentially have lung disease when comparing their actual value to the predicted value. The lower limit of normal also increases. The LLN using the 2012 equation would be 3.46 liters, while the LLN using the 2022 race-neutral equation would be 3.78. Basing an interpretation on comparing an actual value to a higher lower limit of normal could make this black subject appear to be abnormal. While looking at these figures may make someone hesitant on switching to the 2022 race-neutral predicted equations, one must also consider whether the 2012 race-based predicted equations truly reflect your patient population. One of the problems is that there may be no clear way to define each self-identified racial group. While black reference values in general are lower than Caucasian reference values for a given height, age, and sex, racial self-identification may not be based on biology, but rather skin color or cultural heritage. A subject may identify as black. However, they may have one parent who is black and the other parent is Caucasian. Classifying this subject as either black or Caucasian would produce predicted results that are not necessarily correct in either case. Race-neutral reference values would be more appropriate in this case. It would be nearly impossible to question each patient as to their biological background and whether or not they fit into a specific race classification. With more and more of the world's population falling into the mixed race category, averaging the predicted values may be the best solution at this time to a complicated problem. It's only the next step in defining the important differences in what is considered normal and how to interpret results. In the discussion section of the 2022 GLI document, they state, the GLI global reference equations provide a single benchmark to standardize an individual's lung function measurements against sex, standing height, and age. By removing race and ethnicity from the calculation of predicted lung function, we are taking one step toward addressing the disparities promoted by current race and ethnicity-specific equations. The GLI also cautions that the GLI global equations provide an alternative to race-specific equations and highlight that lung function testing alone is not specific to diagnosing respiratory disease. Whether you switch to using the GLI race-neutral equations for FVC, FEV1, and FEV1 over FVC is up to your health center and medical director. MGC Diagnostics has the ability to use either of the GLI reference sets in the Breeze Suite and Ascent software, and can help you change the author in your software if needed. Thank you for watching this video. For more information on Ascent software, or if you have questions, please contact our technical support department at 1-800-333-4137 or email MGC Diagnostics at support@mgcdiagnostics.com.